So if I plug in 0, I get the sine of 0 times the cosine of 0, which is 0 times 1, which is 0. Option E. We'll jump to 3. Again, direct evaluation. Sine of 2 times 0 over 0 gives us 0 over 0, which is indeterminate. So, what kind of manipulation could I go to now? Mackenzie, is that a hand? One of our rules was this one. Only applicable when we're approaching 0, which we are. So how does that... This would have to be the same thing. So what? I think you're saying the right thing. Say it again. You can't just like extract that 2 and pretend it's not there. You can't just like cross this out and pretend that the sine of 2 theta is the same as bringing the 2 out in front and just having the sine of theta over theta. Sounds like that's what you're trying to do. You're just trying to take this sine of theta over theta and apply this and make that 1. And then since the 2 is kind of out in front then, is that what you're trying to say? What would really be the process there? Yeah. Right. So if this is the sine of 2 theta, it needs to be over 2 theta in order for us to, whatever you're taking the sine of has to match the bottom. We can't change this, but we can change the bottom. So in order to do that, I would multiply this fraction by 2 over 2. So the numerator becomes 2 sine of 2 theta, and the denominator is 2 theta. Now this becomes 1. Does that make sense? Was that what you were trying to say? Oh, I didn't hear the multiply by 2 over 2 part. Did you say that? Okay. So anyway, this would become, this would now, when you take the limit as theta approaches 0 on this part would be 1, and then it would just be 2 times 1, which is 2. Option C. There's another way, a thought that crossed my mind. That I'm curious, when you look at this original problem, does anything strike you as looking familiar here? Nobody? Yeah. Double angle, right? The sine of 2 theta is the same thing as 2 sine theta cosine theta. So you could change your numerator using the double angle formula and just keep it over the theta. And so now if you're looking for the limit as theta approaches 0, this part is just 1. And then you can reevaluate, and cosine of 0 is 1. 2 times 1 is 2 again. So it works out if you use the double angle replacement, which leads to the ability to use this again, and then evaluating what's left. Good? So, options. Number 5, because I wasn't here on Friday, I don't have any idea what we did. I mean, I know what we did, but did we come across examples like that? Yeah. So if you're taking the sine of 5x, well, let's back up. Directly evaluate gives you 0 over 0. Do that. If you're taking the sine of 5x up top, if we want this property to be applied, and this is a 5x in our case, then the bottom needs to be a 5x, or needs to contain a 5x also. So I would give the bottom a 5x, but the top also needs a 5x. You can't just multiply just the numerator or just the denominator, because you'll change the value of the expression. Here I'm changing the appearance, but I'm technically multiplying by 1 and therefore not changing the value. And then also the sign of 3x on the bottom would need a 3x on the top to get rid of that. So as far as the limit is concerned now, the limit of this part is just 1. The limit of this sign of 3x and 3x is just 1. And then your x over x cancels. And so this whole thing just ends up being 5/3. Any questions on that? Okay, number 7. Direct evaluation is 0 over 0. So what can we do to this? You'll have to tell me, because you were here on Friday and I wasn't, and I haven't done that video and these notes since last year. Did we talk about, or did I talk about in the video if these were reciprocated? So I said that this one could go either way. Okay, but I didn't for that one. So let's check quickly on our calculator and see if the reciprocal version of that cosine one is also 0. So if I, instead of doing 1 minus cosine x over x, if I do the x over the 1 minus cosine x, what is the limit of this as it approaches 0? Undefined. So that answers that question. So we can't flip those, because when I first looked at that, that was one of my thoughts, is cosine of x minus 1 with the x on top. I thought maybe if we reciprocated it. So, so I don't think I can use that cosine x minus 1 version. Let me just see one more thing. But what about the sine of x version? What would the denominator need for me to work with that? X. So if I gave this x over x, then this sine of x over x would be 1 and would be gone, which would be x squared over cosine x minus 1. If I reevaluate, though, I'm still getting 0 over 0. Now my other thought, and this is a new technique, when I see a binomial, one of my thoughts sometimes is to multiply by a conjugate. Because what happens when I do that, when I multiply by that? What do I get on the denominator? I'm going to have to do it on the top as well. But what do I get on the denominator when I do that? Sarah, what's cosine x minus 1 times cosine x plus 1? Good. And from your Pythagorean identities, what is that? Remember your Pythagorean identities, sine squared plus cosine squared equals 1. That one. So if I was looking to replace cosine squared x minus 1, what could I replace that with? If I subtracted this 1 over, I'd have sine squared x plus cosine squared x minus 1 equals 0. Get that over. So cosine squared x minus 1 can be replaced with negative sine squared x. Everybody see that? So if I replace that with negative sine squared x, now I have my x over sine x stuff going on. I have x over sine x really twice, and another x over sine x. Same thing, that's just x squared over sine squared x. So this part just has a limit of 1. And now I can reevaluate and plug in a 0. The cosine of 0 plus 1 over a negative sign is 1 plus 1, or 2 over a negative sign, which is negative 2. Tricky, but an option. Your Pythagorean identities, your double angle stuff, still options. Now, in hindsight, I wish I had done that right from the start. But I was trying to maybe capitalize on the sine of x over x. Okay, and it didn't work. But if I had done that right from the start and multiplied by cosine of x plus 1 over cosine of x plus 1 and then did the sine squared thing, it would have all worked out still. Okay? It would have come up a little differently in that, let me just do it and you don't have to write this down, but if I did multiply by the cosine of x plus 1, my numerator would be x sine of x times the cosine of x plus 1, and my denominator would have been that cosine squared x minus 1. The denominator would have changed to negative sine squared x. And one of these sine x's over sine x's would have canceled outright. The other one, when you take the limit as x approaches 0, would have been 1, so it would have sort of appeared to have canceled also. And then you directly evaluate, and you get 2 over negative 1. The same negative 2 answer. Okie doke? So just add that like concept of multiplying by the conjugate when you're trying to do creative things with trig. Add that multiplying by the conjugate to your bag of tricks, which now makes me want to go back and look at number 12 and 29 again. Maybe 12, not 29. All right. In 9, the numerator is technically sine of theta times sine of theta, if I want to really spell this out. And the denominator is 2 times theta times theta. So since we're looking for the limit as we approach 0, that has a limit of 1. That has a limit of 1. So this just boils down to 1/2. Good? Okay. Number 11 has us approaching 0 from the right, specifically. Which, maybe it matters, but I'm going to treat it as just the limit as we approach 0 first. And I can use my sine of x over x property if I multiply by what? What would I have to multiply by to to let this turn into having a sine of x over x. Olivia. Radical x. So if I multiply by radical x over radical x, I get root x sine of x over x. Oh, I know why we're approaching 0 from the right. Why? Right, you cannot approach 0 from the left because you can't have a negative under the radical. So if they asked us for the overall limit as you approach 0, we'd have to say does not exist because it wouldn't match from the left and from the right. So that is just x. This part just becomes 1, and then we can re-plug in 0 and we get 0. Good? All right, 13. Why don't you start going 13, 15, 17, 19, and 21 on your own. And while you're doing that, I'm going to play with number 12, and then we'll touch base. A lot of these are direct evaluation, so you should fly right through these. Raise your hand if you're done with 13 through 21. Good. Did you check your answers? The answers are in the back of the packet. Check your answers quickly and raise your hand if you have any questions. Any questions on any of those? Andrew? You plugged in 0, you got 0 over 0? Okay, so we'd want to try to manipulate this, which factoring, rationalizing complex fractions doesn't seem to be an option until you change tangent to sine over cosine. Did you do that? And then what would you multiply by to clear the fractions? Good. So up top, we have to distribute that. So it's going to be t cosine t minus sine t over sine t cosine t. Which does not help, right? So I have a new idea. Let's try to use one of these. So since our denominator has a sine t, if I just had a t up top, t over sine t would cancel, right? So I'm just gonna, so trial and error, complex fraction didn't work. I'm just gonna give the top a t and the bottom a t. Is that gonna work? So this t over sine t is gonna cancel. But then I end up with that again, which is still not helpful. But now maybe my complex fractions would help. Maybe, maybe not. I'm going to try it just because I'm at a loss. So I'd multiply by cosine t. So now I would maybe think about taking the binomial and dividing each term by the denominator, which in hindsight I wish I tried right from the beginning. So that would be 1 minus sine t over t cosine t. Follow that? And then if I'm looking for the limit as t approaches 0, this would still be a 1. This part would cancel sine t over t. And it would be 1 minus 1 over the cosine of 0 is 1. So I'd get 0. So a decent amount of trial and error on that, but again, in hindsight, if I'm looking at the original, I wish I had just done this. T over sine t minus tan t over sine t. Because if I was looking for the limit as t approached 0 on that whole thing, this part would have just been 1 minus, and then this would take some keep, change, flip, sine t over cosine t. So that's keeping the tangent, changing, and flipping. And that sine t would cancel, so it would be minus 1 over the cosine of 0. So I could have gotten there right away. But I didn't see that right away. I was thinking of other things, which is part of the process. Okay? So that answer would be 0. Anything else on that section? Okay. So do me a favor and do the evens for homework, but skip 12. Okay? I mean, because we are going to have a quiz on this on Thursday in preparation, doing the odds, finishing out the odds is also recommended. But I will require